Alright guys, we should recognize that problem. That's the one that your homework was about. So today, to give you the processes of how to solve this thing and get it down to our voltage drops. So let's just get started on this thing. I know the three things we're looking for. I'll just write them off to the right here. Voltage, amperage, and our resistance. And of those three things that we have written over there, there's one that we know for sure. That's our voltage, 120 volts. Okay. Of the two remaining, we can't find amperage. So we can find our resistance total. If we walk through the process and break this circuit down, we'll come up with a resistance total. So let's simplify this circuit. And we'll start with branch 1. And then we'll move over to branch 2. And we'll finish branch 3. And then we'll simplify that circuit to look a lot more solvable. So branch 1, we have two resistors on branch 1. They're in parallel with each other, which means we have to use our 1 over X formula to calculate what the total resistance of these two is. Now if you remember in class, one of the things I said you could do, if both resistors, and only two resistors now, you can't have 3 or 4, but if there's two resistors and they're both the exact same value, the resistance total will be half of one of those. So let's write that down and then we'll check it here in a second. We're going to say that half of that's 0.75, and we'll check out here in a second if that's right. So let's go ahead and get our calculators out. We're going to use our 1 over X function, and we're going to put in the first resistor value 1.5, 1 over X plus 1.5, 1 over X equals 1 over X, and it comes to 0.75. So far so good. So we've got branch 1 solved down to a single resistor now. Guys, I know there's several ways to do these circuits. Okay, I'm just going to stick with the way that I've always done it in class. Kind of stops any confusion. If you know there's a better way and you know that it works and it works better for you, by all means go for it. Okay, branch number 2. Just one resistor there. Nothing we need to worry about that. So we just put down there's 2 ohms of resistance here, 2.0 resistance on the branch number 2. Now let's move to number 3. We're going to solve it the same way with the 1 over X function like we did branch 1, except now we've got 3 of them to do. And it's no more complicated than that, okay guys? So branch 3, we're going to take 0.5, 1 over X, plus 0.8, 1 over X, plus 1.1, 1 over X equals 1 over X. And we're going to come up with, you should come up with, 0.2404. .2404 for that last one. And now we've got this down to a real simple 3-branch, single resistor on each branch circuit. This is real simple to solve for a single resistor. We're going to take these 3 and do them exactly like we did those 3 to come up with the total resistance of our circuit. So our first branch, 0.75, 1 over X, plus 2, 1 over X, plus 0.2404, 1 over X equals 1 over X, and the total the total resistance for this circuit is 0.1668, or you could round that up to 0.1669 if you'd like. Hopefully that stayed on camera. Looks like it did. Okay. Alright, so now that we've got our voltage total, we've got our resistance total, we can find our amperage total now. So let's take this thing, and in order to find our amperage total, we'll go back up here to Ohm's law. We take our voltage divided by our resistance will give us our amperage total. So we'll take 120, we'll divide that by 0.1669, and we'll come up with 718.993. Okay, that's where we're at. We've solved all three of those totals. I'm going to move this camera just a smidge so I know I've got those numbers on the camera. Okay. Looks like it. What are you doing to me? Alright, it's on there. Okay, we've got all three solved. Alright, our voltage total, our amperage total, and our resistance total. So our amperage of 718.993 amps leaving that battery. We better have, when we're done calculating, 7.18.993 coming back. Awesome. Solved that part. Now we need to find out what's doing what on which branch. Okay? So let's take branch 1. What do we need to know? We need to know our voltage, we need to know our amperage, and we need to know our resistance for branch 1. So on branch 1, what do we have for volts? 120. We don't know the amperage. We know a portion of that is going to go down branch 1, but we don't know how much. And that's dependent upon our resistance on that branch, right? So what's our total resistance of branch 1? We solved it a minute ago. Our math's already done. So it's 0.75. Now to find our amperage on branch 1, we simply take E divided by R, which is our voltage of 120, divided by our resistance of 0.75. And we should come up with 160 amps going down branch 1. So 160 amps down branch 1. Everybody with me? Okay, let's do the same thing for branch 2. Branch number 2. We need to know our voltage, we need to know our amperage, and we need to know our resistance on branch number 2. What's our voltage on branch 2? 120, same as all the other branches. What's our resistance total of branch 2? It's only one resistor. 2 ohms of resistance, right guys? So our amperage is going to be our voltage divided by our resistance. 120 divided by 2, we should come up with 60 amps. Okay, so we got 60 amps coming down here. Awesome, you're doing great so far. One more branch to solve. We've done the math on resistance so far. So branch 3. We need to know our voltage again, we need to know our amperage again, and we need to know our resistance again. And voltage is constant on all of our branches. That's one of the rules with parallel. Our resistance for that branch 3, resistance total, we figured it out earlier. That's at 0.2404. Now to find the amperage going down that branch, just like we did on the other 2 guys. Cover up our amperage, we'll take voltage divided by our resistance, and we'll come up with our amperage. So 120 divided by 0.2404, and we come up with 499.168. Okay? Alright, awesome. So here's our checkpoint. We know our total amperage should be about 719 sake of quick math, let's just say 720. If we look at our amperages right now, we've got 500 here. We've got another 220. That makes 720, which means we're on the right track. If you can't add these three up and equal your total amperage, something's wrong. Just stop, back up right now. Don't even go any further. But you should, the rest of you should, everybody should be good to this point. Here's where things get a little dicey, at least you think they do. Really, it's the same thing over again. We want to know the amperage that runs down that leg, right? So we want to figure out the amperage down that leg. We just need to know the voltage on that leg and the resistance of that leg, and it'll give us the amperage of that leg. So our voltage on this leg is still 120 volts. So if we look at branch 1, we still have 120 volts. We still have 120 volts on the left branch here. And we will have 1.5 ohm of resistance. That will tell us the amperage that flows down that branch. So let's take 120 divided by 1.5 and we'll come up with 80 amps. Alright, so we can do the same thing on the other side. Now we know, at least you should have been, if you're paying attention in class, should know that if both of these resistors are the same value, whatever amperage is coming to this split point, half is going to go down one side and half is going to go down the other side. There's another checkpoint. When you're doing your math here, and please do your math, don't just divide that in half, because if you're wrong somewhere along the way, let's say you have the wrong resistor written in here, your amperage will come out wrong, and that'll tell you that you've done something wrong. But if you just split it here, that doesn't help you find any mistakes you might be making. So let's take the second half as well, and we already should have deducted that there should be 80 amps left to come down this leg. So let's look at it on the second half of that leg. Still on branch 1. Our voltage, again, is 120. Our amperage we're hunting for. Our resistance is 1.5. And if we do the math exactly the same, our math will come up with 80 amps going down that other leg. These two 80 amps will come back together, and then they will go and make 160 amps coming down that leg right there. We'll use that again in a little bit. The second branch, nothing in there to mess us up. 60 amps coming in, nothing splits. 60 amps coming back out. Okay, coming down to there. The third branch, we have 3 pieces to that. We have one piece, the second leg. Good, we're going to do it like that. So the first one, we have to solve E, I, and R. And we know that E is 120. Our resistance on that first resistor right here is 0.5. To find the amperage, again, we just do that. Voltage divided by the resistance. 120 divided by 0.5. Should come up with 240 amps on that first branch. $240 amps going down that first one. Let's make that A look like an A. There we go. The middle branch, exactly the same thing. E, I, and R. Our voltage is 120. Our resistance in this middle branch here is 0.8. And our amperage, again, is our voltage divided by our resistance. So 120 divided by 0.8, we come up with 150. So we have 150 coming down that center leg. And the last branch, we have E, again, I, And R, again, you guys are starting to see a pattern. Should be ahead of me by now, really. We know 120 volts sitting on that branch. Our resistance total over here is the 1.1. In order to figure out our amperage, we'll take our voltage, 120, we'll divide it by our resistance, 1.1, and we'll come up with 109.09. I want to round that to, that's probably about, I wouldn't round that up. It's too much rounding. And then when we go back to do our math, it won't calculate right. So our amperage flow down that third one is 109.09. 109.09 amps running down that leg. Okay, checkpoint should be, if I add the amps going down this leg, and the amps going down that leg, and the amps going down that leg, they should equal the amps going into all three, right? So let's take 240 amps going down that branch, 150 amps going down the middle branch, and 109.09 running down that last branch. All right, we should have 499.09. Rounding again, we're so close, we're fine. We're just fine. So we know we've calculated out those three amperages just right. So we still have our 499.168 coming back. Everybody with me so far? Now we need to make sure that we calculated this right. 499.18. So 500 and 220, again, 720. Everything's awesome so far. We're doing great. At this point, we're pretty well done with our little simplified, if you will, schematic down here in the bottom. Just get rid of it, get it out of our way so we have some more board to write on. Now we need to know our voltage drops. Amps at the resistance, or resistor, times the resistance, or the resistor. Okay, that's how we find out our voltage drops. You guys should be tired of hearing that by now, but it works. Our voltage drop for this guy right here, how many amps do we have flowing through here? 80 amps, right? Right here. 80 amps. At the resistor, what's the resistor value? 1.5. So if we take 80 times 1.5, we better come up with 120. 80 times 1.5, and we come up with 120. So our voltage drop for this guy here is 120. Perfect. Second guy, same thing. Amperage at that resistance times that resistance. Amperage is 80, resistance is 1.5, that'll come up to 120 as well. Doing good? Okay. Amps at this resistance is 60, resistance is 2, 60 times 2, 120, boom, 120. Calculating perfect so far. The last one, down at the end, this guy right here. We have 240 amps coming down that branch, times the resistance of 0.5, we'll come up with 120. And if we do the math, that's exactly what it comes up with. The middle branch, amps at the resistance is 150, times the resistance of 0.8. That one I can't do in my head so well, but I think we know what it should add it up to. 150 times 0.8, and it comes to 120. And our last branch, amps of 109.09 times the resistance of 1.1. Do that one. 109.09 times 1.1. And we come up with 119.999999, so 120, if we round that. Those are all source voltages, all the way back here to this dude, and we're good to go. We've solved that all the way through. Hopefully you've done well. Don't forget, use the pause button, back up, play it again. You'll see a test on this sometime this coming week, so be ready for it. You'll see a series test, you'll see a parallel test as well. Alright guys, so be ready for it.